Hi and welcome to the demo lesson for the stateful algorithms. So remember in the theory lesson I introduced to you two different algorithms, the incremental and the cumulative. And in this demo lesson I will show you both of them in action with Apache Spark structure streaming with PySpark to be more precise, but you will find also the version for JVM, so Scala Java API on GitHub. The first part is for the incremental one. It's the easiest one to explain and I would like to start by it. So we start by preparing the data for the stateful processing. We are reading an Apache Kafka topic. We extracting the structure and later we are defining the watermark for the state expiration and the grouping key. Later on we generate a number of visited pages. And this number of visited pages is an example of incremental algorithms because we store here both the number of visited pages and the last event time in the input. And we are using this last event time to generate the expiration time, and we are using the visited numbers just to provide the value we want to our downstream consumers. So this method generates the output every time, even for the pending sessions, and the difference we are going to use to distinguish pending from an ended session is this is finished flag. Okay, so in the data generator I creating both topics. Later I'm generating an event composed of event ID, visit ID, event time and page, and I'm sending all this to an Apache Kafka topic. So typically here I'm sending these records, this data set to both topics because it's easier to code like that. So let me start, I will start the Docker Compose with Kafka, and now I will start the data generator. Okay, we are going to generate the data. Now I will start the incremental approach job. And this incremental approach job should be ready soon. Yes, you can see that we have our visits counted. Roughly, it's not the same numbers. If you take a look at the generation logic, you can see that we have 3 visits for one user, 2 visits for 2 others, and 1 last visit for another user. So what we should have the visit number 1. Yes, with the most rows, and later roughly the same number for visits number 2 and 3, and the smallest one should be the visit ID number 4. Okay, so that's for the state that is pending. Now I will start the Kafka producer. Okay, I will just stop the data generator, do not mess it up. Let's give some time to Spark to finish the processing of the last micro batch. Okay, it should be fine right now. And now I will send an event that will stop all the pending sessions, just to show you that the is finished flag can change, and that also we have this logging message that we added in the first if case, and from that we generate the session, and of course we remove the session from the state store. Okay, that's for the incremental approach. Let's stop it. What about the cumulative approach? So here the logic is a little bit different. The logic here, well, for the input is the same, but for the output is not the same. So I had one to do that I already solved and didn't remove it from the comments here. And yes. So here the idea is to generate a visit statistics. The visit statistics that are composed of the start time and of the duration in milliseconds. So here if we would like to use the incremental approach, we would typically take this duration and store it in the state just by and in each micro batch we would compute the difference and the execution time of each micro batch. But the problem is well known. I think that you see it, is that it doesn't deal well with late data, and yeah, if you integrate late data, you can have much longer visit that you really have. And that's why in the state I'm storing only the first event and the last event timestamps available so far, and in the end I am doing the subtraction between both of them to get the correct duration. So it's a cumulative approach because, as I explained to you before, the incremental one would only store this duration as a state and add new values to it every time. Okay, maybe I will just give you some more explanation why it's different. So if we would like to implement this as an incremental, let's see what happens. We have our data for, let's say, 10, 10, 10, 10, 20 to be to keep the example very simplistic. So the duration for this is 20 minutes, or later on we have another session. So let's say we have 30, 10, 40. So here the duration is 10 minutes plus 20 minutes from the state, which gives 30 minutes. It's correct so far. But the problem is that now, for whatever reason, of course, please always take all the examples I'm giving to you in your specific context, because here I'm assuming that the data can be very late, but if in your consumer, if your producer guarantees that the things I'm explaining to you will never happen, well, typically you can use the incremental approach as well. But let's a bit off outside of any context. I don't know all the context I don't know all the context that can be in data projects. So that's why always please take these examples and apply them to your context. So in my context, I can have the situation like that. I can have data for 9:50, which is very late, and later I can have the other part for this, so 10 and 11. And what happens now is now I have the duration of 1 hour and 10, and if I add it to 30 minutes, I have the duration of 1 hour 40. Okay, so let's keep it in mind. And what happens with the cumulative approach? So let's take the first one. We have the mean, which is 10. We have the max, which is 10, 20. The duration here is correct. Now already here we have some discrepancies. The mean remains the same. The max increases. So here our duration is 40 seconds instead of 30 minutes, sorry, instead of 40. Why so? Simply because here we just lose the information between this and this, because we reduced the state so much that we don't have this kind of detail, and that's why we miss it and generate invalid duration. But anyway, let's continue now with our late data. So if we integrate late data, we obviously update the mean, and we update also the max because we got a new record for it. But here the duration, as you can clearly see, will be 1 hour and 10 instead of 1 hour 40. So that's the reason the incremental approach doesn't work everywhere, and mostly I would say it messes a lot in all the stateful aggregations that relies on the state, because if we had done just a simple count, the result will be the same every time. But here you can see that we are comparing some temporal values, and already in this case, when we don't have any late data, there are some differences. So that was for the few words of explanation, and let me now start the job. So I will maybe add it to the README later, just to you have it in mind. And okay, I can start my cumulative approach job. Sorry, I still have the data generator to run before. Okay, I have my data generator. Okay, it's running. Incremental I can close, and I will run the cumulative approach. Just clean up some logs before. And yes, you can see the duration is continuously generated. We have the same duration because the timestamp is the same for all the events. And yes, we have it. It increments every time, and now I will just stop it and send an event to close the sessions, exactly as I did before for the incremental approach. Okay, I have it, and yes, you can see that we generated the final output for all the pending sessions. Okay, that's all. So remember, incremental state algorithms are very efficient from the memory and resources usage, but as you saw here, especially with the second example, when I compared the same problem but implemented with these two different methods, you clearly saw that the outcome will not be the same, and the outcome will be incorrect, invalid for the incremental approach. Especially, I think that you will see the problems mainly with all the operations involves time, not only because of this incremental approach, mostly because the stateful and stream processing relies on time much more than batch, that has, I would say, a little wider range of data to process. Here it's really small, and if something goes unexpected, like you get late data or you miss some data in between two executions, well, it may not be ideal to use the incremental algorithms. Thanks for watching, and see you in the next lesson.